Hi, here's part 1 of the Unit 2 and review video. This first question, finding equations that are equivalent to 3x minus 6 equals 2x plus 9. The easiest thing to do is just start solving for it. So if I notice that maybe, well, let's see, if I go minus 3x on both sides equals negative 6 on that side, and then I'll get negative x plus 9. That is one of my options, so that's equivalent. Maybe let's start over. Let's erase all that. Maybe if I do the opposite thing, so I go minus 2x on each side, I get x minus 6 equals 9. I'm going to add 6 on each side. I get x equals 15. That's one of my options. And that's actually my solution. So all of my equivalent equations will have the same solution of x equals 15. So I can see here I would have to divide by 5 to get x by itself, and that'd be the solution. So if I divide by 5, that definitely, 3 divided by 5 is definitely not 15. So that's not one of them. And then if I add 6 on each side, that will give me 17, so 3x equals 17. And if I divide by 3, that definitely won't be 15. So we can see that those two are not options because they don't have the same solution. On solving for x. On this one, I am going to distribute this 4 first. I'm going to get 3x minus 1 is equal to 4x plus 8. And I'm going to get all my x's on one side. So minus 4x minus 4x. That'll give me negative x minus 1 equals 8. I'm going to add 1. I get negative x equals 9. Since I have a negative x, I have to divide or multiply by a negative 1. And that will give me x equals negative 9. Okay, on number 2.2, I notice that this 2x and the 6x are on the same side, and I can combine them. So I get 3 equals 8x plus 11. I can combine them because they both have x's. I'm going to subtract 11. So I get negative 8 equals 8x. Divide by 8. Negative 1 equals x. Okay. This next one, I'm going to do a little bit opposite. I could distribute like how I did on 2.1, or I'm going to divide the whole thing by 5 to get rid of that 5 out in front. So now I have 3x minus 4, the same thing that was inside the parentheses, equals 10 divided by 5 is 2. I'm going to add 4 on each side. I get 3x equals 6. Divide by 3 on each side. X is equal to 2. Now I'll use that same type of logic with this 2.4. I notice that 9 and 3 that are on the top of the fraction both can divide by 3. So if I divide them each by 3, I get 2x plus 1 is equal to 2. So I'm just simplifying that fraction. And I'm going to subtract 1 on each side, so I get 2. Oh, I made a mistake. 9x divided by 3 is 3x. Subtract 1, so I get 3x equals 1. I'll divide by 3. Divide by 3, x equals 1/3. And keep it like that as a fraction. It doesn't need to be turned into a decimal. 1/3 is 1/3. Okay. With this next one, I'm not going to divide by that negative 7 like how I did on number 2.3. That's only because 10 and 15 don't divide nicely by 7, so I will distribute this first. So negative 7 negative 7 times negative 2m is going to give me positive 14m. And negative 7 times negative 1 is going to give me a positive 7. I still have 10m plus 15 on this other side, and that same symbol of the less than or equal to. Now I'm going to, let's see, I'll subtract negative 14m, subtract 14m. So I get negative 4m plus 15 is less than or equal to 7. And subtract 15, and that gives me 8, negative 8. So negative 4m is less than or equal to negative 8. And here is, I'm going to divide by negative 4, but since I'm dividing on each side by a negative number, I have to flip the sign. So that's going to give me m is greater than or equal to, and negative 8 divided by negative 4 is positive 2. Okay. This next one here is the work that Daniel did to solve 8x plus 2y equals 100 for x. Explain why this is solved incorrectly, so let's go through each part. 8x plus 2y equals 100, minus 2y minus 2y. That looks okay. This is the opposite operation, or inverse operation. So then it wasn't subtracted from 100, it's just written as subtracted 2y. Now we're going to subtract 8, subtract 8. Well, if I'm trying to get x by itself, 8 is multiplying by x. I need to unmultiply it or divide it, not subtract it. So 8 should be divided, not subtracted. Okay, now let's solve this correctly. So I'm going to subtract 2y just like it was at the beginning. So I get 8x equals 100 minus 2y. I'm going to divide by 8. And I could honestly leave it as that, but it does turn into a fraction, another fraction. I know that all of these divide by 2, so I could do x is equal to 50 minus y divided by 4, and leave it as that. Or I could keep it as 12.5 minus 0.25 y. But I would prefer this one first, this one second, and this one last. So I'm going to circle this one as my final answer.